Hello and welcome to our first in the series of MeetTeamAtlas. My name is Amarpore and I'm pursuing my doctoral studies as an early stage researcher working at University of Verona and Polytechnic University of Barcelona in Spain. Now, since this is the first session, let me introduce Project ATLAS. ATLAS is a Marie-Curie joint European doctorate school that stands for autonomous intraluminal surgery. Intraluminal surgical intervention is a challenging branch of minimally invasive surgeries that rely on steering of flexible instruments through bodily lumen or vessels without the need of an incision. Examples of such interventions include colonoscopy, urethroscopy, cardiovascular, catheterization, etc. Our objective is to develop smart flexible robots that autonomously propel through complex deformable tubular structures. Now, this calls for a seamless integration of sensors, actuators, modeling and control. And our vision is to step up the available surgical robotic platforms by introducing autonomy and further to enable their availability in developing countries. This would lead to more accuracy and precision in various surgical procedures, leading to less patient complications and in turn less mortality. The project is coordinated by University of Leuven in Belgium and is implemented by a consortium of 7 universities and many industrial partners. In this series, MeetTeamAtlas, we will chat and introduce our early stage researchers and principal investigators and talk about their expertise, projects and informal hobbies. So first in our interview today is our beloved, the representative of all ESRs, early stage researchers, and a friend and colleague to me, Mohammad Ansari. Welcome, Hasan.
Hi. Thanks, Aman.
So let me introduce Hasan. Hasan received his Bachelor's of Technology BTech degree in Mechanical Engineering from the Indian Institute of Technology, Patna, and he continued with his Master of Science in Mechanical Engineering at ETH Zurich in Switzerland with a focus on microrobotics. His master thesis was under the guidance of Professor Bradley Nelson, and he used micropillars as intracellular viscosity sensors. He further worked with guest scientists at Physical Intelligence Lab at the Max Planck Institute of Intelligent Systems under Professor Metin Sethi. Hasan is currently part of the ATLAS project and he is enrolled at the Biorobotic Institute of Scuola Superior Sant'Anna in Pisa with a joint degree in KU Leuven in Belgium. So Hasan is a member of IEEE Robotics and Autonomous Automation Society and a student member of IEEE. So Hasan, what a pleasure it is to have you here today. And
thanks, Aman.
Welcome here. So let's begin with this informal session. First question to you: How did you get in robotics? What got you in robotics?
Yeah, well, I mean, like many of us, I've always been very passionate about robotics, and even as a bachelor student. So, taking several workshops and then later organizing them, even building some simple stuff as part of extracurricular activities. And then it's during my master's program that I got an opportunity to work with, as you mentioned, Professor Brad Nelson, who is a pioneer in the field of microrobotics, magnetic and acoustic propulsion, that kind of stuff. So, of course, I mean, I took the opportunity with both my hands and I'm glad I did, because it's that experience that really got me into this narrow field of magnetic actuation within robotics. And it's the field that I'm currently working on. Even later, I've had the opportunity to work with great researchers and mentors, Professor Metin Sethi in Germany, as you mentioned, and Professor Van der Putten in Belgium right now, and Professor Arianna Menciati in Italy, who have motivated and continue to motivate me to, continue working in this field and enjoy it.
Oh, that's really a fascinating story about your growth from a bachelor student to what you are right now. Can you talk more about your expertise of your lab, which you're working on right now?
Yeah, I'm sure. I would love to. So as you mentioned, like the other ESRs, I am also enrolled in 2 labs. One is the Biorobotics Institute in Scuola Superiore Sant'Anna in Italy, and one is KU Leuven in Belgium. Right now, I'm spending my time in Italy. So at Sant'Anna, my group is the surgical robotics and allied technologies area. The focus of our lab is actually very wide. We work on several areas under the general surgical robotics area. One of the areas is the development of realistic phantoms for the training of the medical personnel. Another area is the development of capsules, catheters, that kind of stuff for diagnosis and targeted therapy. We also work on micro-robotics, magnetic actuation, and ultrasound imaging. And finally, we also work on developing artificial implantable organs for the treatment of chronic diseases. As you can probably guess from this wide variety of work that we do, that we have expertise in really diverse fields, from materials to controls to sensing to actuation and everything in between. I actually haven't spent much time in my lab at KU Leuven, but from what I learned from my short visits there and also from what I hear from my colleagues, they are very good with flexible instruments, catheter design, sensing, shape estimation, control of continuum robots, that kind of stuff. So I mean, while enjoying my work here, I also really look forward to spending my time in the other lab and taking advantage of the expertise there.
So that's very interesting. And surely I believe that using flexible instrument, we can reach the in-depths of our human anatomy. So since you mentioned you are doing a PhD, doctoral studies in catheters or robotic assisted surgery, can you dive deep into what specifically your PhD is about?
Yeah. So, I mean, if I were to sum up my PhD in one sentence, it would be I am working on novel magnetic approaches for cardiovascular applications. Of course, I mean, we can expand on that as much as we want, but keeping it short, considering the time and the occasion. The thing is that our heart actually is very well protected within the body, and it is not easy to access it, right? And understandably so, because considering how important it is for us to be, have a working heart, it needs that protection. So when a surgical intervention is required for whatever reason inside the heart or around that area, you actually have to work very hard to reach it. You have to cut open the rib cage, and then that makes the surgery very invasive, right? So now the researchers, I mean, for quite some time now, the researchers have shifted to using catheters and accessing the heart via the arteries that emanate from it, so that the procedures that were performed earlier being so invasive are now not so invasive. Even so, I mean, of course, if there's a very complex procedure, you still have to go through all that invasiveness of the procedure. But now, at least, we have many of the procedures which are moving to this non-invasive method. But the thing is that these catheters are inserted into the arteries and they are pushed, right? And we hope that the tip of the catheter reaches a particular place, because that is the most important part of the catheter. That is the part that will be doing, that will have the functionality that you want, or will be doing stuff that is required of the catheter. So as you can imagine, pushing the catheter from behind and controlling the tip is a very difficult endeavor, right? So that's where I come in, and I try to make the catheter tip magnetic so that we can control the orientation and the direction, the deflection of the catheter tip while it is being pushed using external magnetic fields, right? So that is the plan. That is that the catheters become steerable so that the burden on the surgeon to manipulate the catheter while performing the surgery is reduced. At the same time, I'm also exploring some ways to extract the maximum potential out of these magnetic catheters. So I look at ways by which I can use these magnetic catheters to filter out the therapeutic magnetic nanoparticles from the bloodstream. In a lot of studies, researchers show that therapeutic nanoparticles can be used for targeted drug deliveries inside the body, but but very few of them talk about what happens to these nanoparticles once they do their job. And again, that's where I come in and I say that, okay, magnetic catheters can be used to, extract out these nanoparticles from the bloodstream once their job is done. So those are the two areas I focus on, and hopefully that is the gap that I want to address and fill.
Surely, I believe magnetic applications for controlling the catheters could be and surely would be a game changer in this paradigm. And you mentioned about the advantages of using a less invasive surgery over open interventions or more invasive surgical procedures. But do you see any limitations of magnetic applications, such as magnetic heating or different effects on a human body?
I mean, the good thing about magnetic applications is that if you can have, I mean, you need to have a very small magnet inside the body, right? Considering the space limitations that we have. But the good thing is that if we keep reducing the size of the magnet inside the body, we can increase the size of the external magnet we use. So that comes very handy, that kind of negates the limitation on size we have. And magnets are being used in hospitals even now. I mean, if you go to get your MRI done, the magnetic fields used are quite strong. I know researchers have already started working on 11.5 Tesla MRI machines. I know that 7 Tesla MRI machines have already received approval from the FDA. So from that point of view, I think it's very safe. And also because MRI machines are so commonly used already in the hospitals, I think the staff is already trained in how to deal with the magnetic fields and how to take precautions on that. So I think in that sense, you don't need any extra effort to be done. Maybe only minimal extra training would be required. Also, I mean, I know that magnetic fields have this reputation of producing heat inside the tissue, but that only comes into play when there are, either electromagnets involved, which produce a lot of heat, or when the magnetic fields are being rotated. So that creates, if you have a magnet inside the body, then that also starts rotating, and that creates heat due to friction. But we don't have either of those in our case. So I think we can be safe. I mean, we can be sure to say that this would be a much safer thing to do.
I see. I see. Now, again, back to the question that when we think of robots operating in operation theater, we should ensure safety. So, what's your take on magnetic applications for controlling catheters, and how do you ensure safety with this technology?
Yeah, I mean, as I said, even permanent magnets can pose some sort of safety issues, I guess, if not handled properly, because a lot of the instruments used in the hospitals are magnetic, so they may cause interference and other unnecessary interaction. But I mean, the good thing is, or the encouraging thing for me is that hospitals already have dedicated rooms for MRI machines where such precautions are being taken, to handle magnetic fields and how to work with them, how to avoid unnecessary interaction, that kind of stuff. So I'd say that with minimal extra proper training, there should not be any significant safety issues arising from it.
I see. Okay. And what's your vision regarding robotics in general? This might be an out of context question, but uh, I think we dive quite deep into surgical applications. But just looking at it vaguely or in a broad sense, what do you think would be or is your personal vision about robotics?
Well, I mean, we are working on surgical robotics, right? That is our project. So, I mean, my vision is to see technology and robotics support surgeons and enhance their abilities even further and expand their reach, basically. So, a lot of the medical procedures we see or that are being performed in hospitals require extensive experience on the surgeon's part, and that limits not only their availability time wise but also their availability geographically area wise. So the doctor has to be physically present somewhere to do that procedure, and he has to actually spend time. So if we can supplement the surgeon's abilities to bring down this experience bar, then maybe we can expand the availability of complex medical procedures to even more patients, so that so we reduce the waiting time for a procedure. Maybe we make complex procedures available even to remote parts of the world. So that would be something I really look forward to, and I'm working towards that.
Sure, sure. And how do you think Atlas, in general, is helping you reach your vision? Uh,
I mean, it's a great opportunity, right? Because not only are you working in two different labs, so you get expertise from both the labs, but you also have several other industrial partners you can learn from, and then Atlas also organizes many training activities for your specific project. So so you get to learn a lot in several different fields of your project, and you continuously keep improving and learning. And not only that, but also we have very regular meetings between the researchers and the supervisors, not just the our personal supervisors, but also other supervisors involved in the project. So there's really a lot of interaction going on, and a lot of planning, and learning from each other's experiences. And also, as you know, we are 15 of ESRs working on this project, and we regularly meet with each other, whether on Skype or in person, and we discuss what our requirements are and how we can help each other, how we can learn from each other. So I'd say that Atlas really helps me in learning what I need to learn so that ultimately our vision can be achieved.
Now, since you're working on the cutting edge technology of surgical robotics, what do you think would be the future of surgical robotics in general, and especially would we in near future see some autonomous, completely autonomous surgical robots?
I think, I think the future of autonomous intraluminal surgery is quite bright, frankly, and more and more effort and resources are being put into this field, and we are already starting to see the results. Just like the Da Vinci robotic system, which has already become quite popular in the hospitals for robotic surgery, I expect we'll see more and more similar surgical systems for intraluminal applications soon enough. But saying that we will have fully autonomous systems is a bit far, I would say, because we first have to really make sure that the patients and the surgeons trust these systems enough. So we have to first build that trust deficit that I would say currently patients have, and then maybe we can think of making fully autonomous intraluminal robotic surgical systems.
Now let's take a step back. I think it's important to understand why we are moving towards more autonomy, or why we are targeting autonomous surgical robots. Can you elucidate more on what advantages, or what why would it be a paradigm shift or a game changer when if we have uh, totally or fully or semi-autonomous robotics?
Yeah, so for now, I visited a surgical room and witnessed a surgery, actually, a cardiovascular surgery, this year, last year, actually, last year, January, right? And I see that during such a surgery, you have several people assisting the surgeon with the surgery, and each with a particular task to do. And each of those tasks come with the requirement of some experience on the assistance part, right? And it's possible that in some hospitals in some remote part of the world, or even in the regular hospitals, that particular assistant is not available. So that experience, expertise is then becomes missing, right, in the surgical theater. So we can kind of fill that gap by making it autonomous. So if we can make it so that the experience of the assistant can be replicated or can be learned by the autonomous systems, then we have much more freedom in providing better healthcare to the patients. And that's why I think robotic systems, and particularly autonomous robotic systems, will help.
Absolutely, I completely agree with you on this point. So, what are your plans after this PhD? Would you want to continue in academia research, or would you like to shift into industries, or do you have any random out of the box plans?
No, 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 nothing out of the box, just the usual boring career path everyone takes. In the long run, I do want to go back to India and continue in academics or research there. If I can start my own research group, that will be the best.
Perfect. Taking the safest path.
Yeah.
So now moving towards our informal activities, what are your hobbies which you try to pursue apart from work when you're not in your lab?
I like cooking Indian food, so I spend quite a bit of time doing that every week. And even though I'm in Italy, I actually eat Indian food prepared by me almost every single day. So yeah, when I'm not spending time working in the lab or cooking at home, I do some other stuff like playing Counter Strike, which I've picked up now. Yeah, so I've even started following the professional Counter Strike tournaments again after quite a bit of time. I think the last time I was doing that was during my bachelor's. I mean, it's the I mean I think it's the effect of the lockdown and being at home too much more than one should be. It makes you pick up weird hobbies, right? I mean, I guess watching professional Counter Strike tournaments is a weird hobby. I would say. Yeah, so that's what I do, and occasionally I enjoy watching a movie. Sometimes I bought a very good projector for this very purpose.
That's interesting. Something out of work. All right, Hassan. So it was really great talking to you today. What would be some of the advices that you would uh, give to some young leaders thinking of research opportunities on similar topics?
I mean, I can give a couple, I guess, but both very general, not very specific to this topic. I mean, if someone wants to build a career in research, then they really should be very passionate about it. Research throws up quite a bit of challenges, and the only way you can deal with them is if you are really self-motivated. Otherwise, I mean, if you're doing a PhD just because someone's pushing you to do, then I think it would be, and I mean, as soon as you start facing challenges, then it becomes, I mean, you feel demotivated, and then the entire purpose of the PhD is thrown away. Yeah. So that's the first thing, and the other thing is that um, when you do a PhD, it's really important to find good supervisors. They are the ones from whom you'll be learning the most. They are the ones you'll be taking collective decisions with. So I think it is extremely important to find good supervisors with whom you have a good professional relationship. I have been lucky to find such supervisors, both of them in Belgium and Italy, and I hope that other researchers do so too.
How has COVID affected your research? Do you get I'm sure it would have limited your access to the lab, and since your work is largely based uh, on mechanical objects, mechanical instruments, so
Yeah,
how has it changed over this last unprecedented or strange times?
yeah. So I mean, as you rightly pointed out, that my work is mainly based on physical lab activities. Having access to equipment, machines, labs is very important to me. But since COVID has struck, I have had to, book slots for the machines, for labs, etc. And then that has kind of restricted my lab activities. But then, I mean, it's not it's not such a bad thing because the time you don't spend in the lab, you can spend elsewhere in your office or at your home doing some other stuff, building your theories or reading up on your on literature survey, things like that. And yeah, I mean, I guess it's the only safe way of continuing with research right now because the situation is unprecedented. Otherwise, if we let go of these restrictions, and who knows, what the outcome will be. So it's taking the best use or making the best use of what we have.
Surely, I do hope that 2021 would be sort of opposite in some terms to 2020, and I wish you a safe
That,
and good health and prosperous 2021. And
that's the dream, right? Having 2021 better than 2020.
okay, so thanks a lot, Hassan, for taking our time. It was indeed a pleasure to have you, and I hope we get some positive reactions from from our community.